and shipping costs would exceed the cost of the batteries in most cases. Batteries Plus has locations across the U.S., so these particular batteries can be picked up locally by you folks watching. If you live in an area where solar is more prevalent, then you may have many more choices. But Battery Plus is nationwide, and this particular battery will work for anyone, and it's within driving distance for just about anybody watching this show in the U.S. So, to recap, when sizing your battery bank, use, as a rule, a minimum of 2 days, but not much more than 5, and get as much capacity up to that 5 days as your budget will allow. Even though my system's sized at only 2.5 times what I consume, I've gone 5 or more overcast days in a row. Now this is partially due to me sizing the generating side at 1.5 times what I need as well. There are many other nuances and details you need to know about batteries, and we'll cover everything you need to know, both about the batteries, the box, and everything in it, on it, and tied to it in a future part of the series. Obviously, you're going to have to install your solar system in an area that receives full sun for most of the day, but it's a bit more nuanced than that, especially if you install a smaller off-grid system like ours. There's going to be 2 things that you're going to have to know. First, the sun isn't at the same elevation throughout the year. And second, you're going to want to try to locate your panels as close to the batteries as possible. When picking a spot to locate your panels, you have to consider that the sun will be lower towards the horizon in the winter and closer to directly overhead in the summer. While later in the video, I'll suggest that you need to tilt your panels as well. For now, know that you must locate a spot that will be in full sun throughout the year. How do you know where the sun will be in your location? There's a link to a calculator down below in the description. In my case, up north, the sun dips to just 24 degrees above the horizon in the dead of winter, but it rises to 72 degrees above the horizon in the middle of summer. You'll have to determine your range and make sure that your panels have an unobstructed view of the sky. You might think that I'm on this roof because I'm about to tell you it's the perfect spot to mount your solar panels. While roofs are good for antennas and for folks that have more money than they know what to do with, it might not be the ideal spot to mount your solar panels. The first thing you have to consider is the age of your roof. A panel like a Renogy is going to last you a good 25 years, about the same lifespan as this roof. How old's your roof? Unless your roof is brand new, you'll be removing your system at some point to repair the roof. I guess if the grid went down tomorrow, it wouldn't matter, but there's 2 more reasons you might want to consider otherwise, and both have to do with efficiency. While it's possible to get a tilt system for a roof mount, it will entail you climbing up on the roof to tilt the panels. Most roof pitches point the panels towards the sun at an angle that favors summer power generation. If you can easily walk on your roof, this is the case. When winter hits and the sun moves lower in the sky, output will be drastically reduced if you can't point the panels towards the sun. For quite a few of us, we get snow in the winter, which causes 2 problems. First, you can't get to the panels to tilt them, and second, it kills power generation when they get covered. If you can't easily clean them off, you've effectively killed your winter power generation. Now, I'm not saying that you shouldn't mount your solar panels on the roof. What I am saying is to consider these challenges if it's the only place that you have to mount them. In my case, I decided to make a frame that would put them about 8 feet up in the air and give them an unobstructed view of the sky no matter what time of year. It also serves a second function as the rec yard for the chicken prison. Building a system that actually tracks the sun would be best, as the panels are always pointed directly at the sun. But this being a budget build, and also out of my budget, maybe we'll have to save that for a future video. Now you can use whatever you want to mount your panels, from treated 2x4s to junk laying around the house. In my case, I built the frames out of Unistrut. Unistrut is available at any home improvement store, usually in the electrical section. It's sturdy, inexpensive, and the holes just so happen to line up with the Renogy Z brackets, so I didn't even have to bring out the drill. For the tilting mechanism, I use screw hooks and gate straps. I got those from my local Menards. Using my mounting system, I can adjust the panels tilt once a month to ensure they're pointed directly at the sun. All I have to do is remove this bolt and adjust as necessary. Your second major consideration in locating and mounting your solar panels is their proximity to the batteries. While the rule of thumb is to get them as close as possible to the batteries, this isn't always the case. And this is due to the fact that solar systems use low voltage electricity. You see, the more and more power that you try and transmit at a low voltage, the thicker and thicker the cabling must be. And this can get very costly. The problem is it's very nuanced, but there's many tips and tricks that we can employ to get around some of these limitations. But at this point, we're ready to start wiring stuff together. Once you have your panels selected and have picked a place to mount them, you're going to have to get the power from the panels to the batteries. In the last video, we said that mounting your panels as close as possible to the batteries was important. This is due to a simple electrical principle that as electricity travels down a wire, it loses energy due to resistance. The longer your wire run, the more energy is wasted due to resistance. This principle plays an especially important role in solar electricity because the lower the voltage, the more we have to deal with this phenomena. And as far as solar power is concerned, it's pretty low voltage. Resistance in the wire is directly related to the thickness of the wire. The thicker the wire, or the lower the gauge, the less resistance in the wire. Theoretically, we could mount our solar panels as far away as we wanted to from the batteries, but the wire gauge in between would have to be so thick that it would be impractical. Ultimately speaking, it's the cost of the wire that limits us from mounting our solar panels wherever we want. At this point in the series, many of you watching are designing and planning your own off-grid solar systems. And due to your differing needs, you're going to come up with different configurations, different number of panels, and so on. Now, I can't go through every scenario that's out there, but what I can do is show you the different configurations that I faced and show you how I wired my system. At this point in the series, you know that our system contains 4 100-watt Renogy panels. If your system consists of more than one solar panel, you're going to have to make a choice in wiring. You're going to have to wire the panels together somehow to transmit the power from the panels to the batteries. And just like in our battery video, you're going to have to make a choice between series and parallel wiring. Each one of these Renogy 100-watt panels generates 18.9 volts and 5.29 amps under full sun. Multiply those two numbers together and you come up with the 100 watts listed. If I were to take my 4 panels and wire them in parallel, that's bringing all of the positives to one point and all of the negatives to one point, and then measure the output, I'd end up with 18.9 volts and 21.16 amps. Multiply 18.9 times 21.16 together, and you get roughly 400 watts. This is because in a parallel system, you add the amperage together and the voltage stays the same. Conversely, if I were to wire them in series, taking the positive of each panel and connecting it to the negative of each panel, and then taking my reading from the 2 remaining positives and negatives, I'd get a reading of 75.6 volts at 5.29 amps. Multiplying these two numbers together, again, gives me roughly 400 watts. This is because in series we add the voltage together and the amperage stays the same. So, as you can see, wiring the panels either way comes up with the same 400 watts, but with 2 very different results for volts and amps. Now, I'm not going to tell you which way is best per se. What I am going to do is show you what happens when you wire the panels either way, and then let you make the decision. Let's take a look at my situation and how wiring the panels either way would affect my decisions. When locating my panels, the sun and spousal zoning ordinance